Hello and welcome back to Physics for the 21st Century. Once again, my name is Greg Perugini, and today's topic is rocket propulsion. So it seems like a fairly straightforward subject, right? It's an application of Newton's third law, in that if we have a rocket here, what I have coming out the back of the rocket propels the rocket forward. The issue we have, though, is that as this is propelling forward, we're burning fuel. The mass is going down of what we're propelling forward. Mass is changing over time. So the velocity changes because the amount of force going out the back has to move less of the rocket. So how do we write that down mathematically? Now, this gets a little confusing here, and you can study this if you wish. But we're looking at a couple of factors. We're looking at burn rate. Okay? What do we mean by burn rate? It is the change in mass over a given time. Now, using Newton's second law here, we can say that the force, the thrust that we're giving here, is equal to the velocity of the engine propellant, we'll just write it as velocity ng, times that burn rate, change in mass, for a given period of time. So often you're given the thrust at a constant rate, a mass that you're burning over a given time or given the burn rate, and then you have the velocity coming out the back of the engine. As I said, this is going to change logarithmically because as we go through time, we have less mass in the fuel. So we have an equation that we can write based on that. Velocity of the craft itself at the end minus what it is initially is equal to the velocity of the engine times the logarithm, the natural log, of what we have as start, the mass initial, what we have final, the mass after the burn. So that's what this all really boils down to, is these things. So what we have is a burn rate, change in mass over time. We have the thrust out the back we can calculate given the velocity of the engine times that burn rate. Velocity of the engine material coming out the back, and this equation, velocity final minus velocity initial, is equal to the velocity of that engine thrust times the natural log of mass initial over mass final. As always, this becomes easier if we do an example. So let's do one. So let's say we have an average thrust from an engine of 8 newtons. Not too much. So that's our average thrust. For a total of 6 seconds, this engine can do this thrust. So we have those two factors. Then we also have the factor of the fuel. Have 4 kilograms of fuel that burns in that period of time. And the rocket, without the fuel, is 5 kilograms. So we want to know, when we do this burn, what is the velocity of the rocket? That's what we're trying to figure out. Well, force, first of all, we can figure out, we know the force is 8 newtons, so remember that equation. That first equation dealing with the burn rate. So I know the answer to most of this equation. I have an 8 here. I have the mass is equal to 4 kilograms of fuel that we're burning over a period of 6 seconds. Right? So if we do this equation, we can solve for velocity. We can solve for velocity of the engine thrust. 12 meters per second in this case. Because we have 2/3, 8 divided by 2/3 is going to give you that. So once we have that, if we are starting from rest, we can use the other equation here. Velocity final minus velocity initial is equal to velocity of the engine thrust times the natural log of the mass initial over the mass final. Again, what do we know? The mass final, we burned all the fuel, so all we have left is a rocket. The mass initial is the rocket fully loaded with fuel. That's a 9. And we know this velocity of the engine, that is equal to 12. So I'll give you a second. If we're starting from rest, you should be able to figure out the final velocity of that rocket. With a burn of 6 seconds, with 4 kilograms of fuel, that can give 8 newtons of thrust for that 6 seconds, a 5 kilogram empty rocket with that fuel, at the end of that 6 seconds, would give you what? Velocity final, you should get is 7.1 meters per second. Now, obviously we can get into an issue here, and you need to understand the inverse of the natural log, right? What is the inverse of natural log? Right? Exponential e. Okay? Because you may be given one of these and solving for the other, given the velocity final and the thrust, what was the initial mass, or for that matter, how much fuel you'll need. So you may be given everything in an equation, such as the velocity final, it goes 12 meters per second. Or excuse me, let's use the example we have here. It's going 7.1 meters per second. The velocity of the engine as 12 meters per second. What is the mass of the fuel? You know, perhaps, that portion. So obviously, you need to figure out what this is by redoing this equation So think back to your algebra and understand how to do that. So that, again, you would use E, the transcendental, right? And solve that equation for the mass final. In this case, when you do that, you would get a 5, because we've already figured it out here. And given that, you know that if at the end you have 5 and at the beginning you had 9, of course you burnt 4 kilograms of fuel. So, in conclusion, know your log button, the ln button on your calculator. Typically it's a big ln, natural log. Know the problems and the variables. Know to go back and forth from natural log, inversing it to the e function. Know the types of problems and variables. You'll have a limited period of time, so practice. And good luck.